Hello guys, welcome to the channel MyOneTeacher. So in this video, we will cover a topic rate of change. So let us start. So rate of change is part of this chapter, Introduction to Differential Calculus. But in this video, we'll not discuss about calculus. In some other video, we'll come to this topic, calculus. So rate of change. Let us understand this. So let me explain you one example. Suppose you're traveling from point A to point B. Suppose in first 1 hour you cover 45 kilometer. Next 1 hour you cover a distance of 40 kilometer. And in next 1 hour you cover a distance of 42 kilometer. Now what is the rate? How it's changing? That only we learn in this chapter. Suppose for example, if you invested some money, okay, so how your money is increasing, at what rate, that we can calculate. So rate means you can say comparison of two quantity. For example, in first case I am comparing distance with time, okay, and in other one I am calculating the amount, or I am comparing the amount with again time. Okay, let's check here. See, rate is comparison between two quantities with different unit. So distance, for example, in kilometer, in time you can take in second or minute. Okay, so that comparison is rate. Now the rate of change can be constant. How? If I take a container and start adding water on it, okay, suppose in first 1 hour I add 15 liter, and in next 1 hour also I added 15 liter. Okay, let me show you the table. You can see time and volume. Okay, volume in liters. So initially it was 0. So after 1 hour the volume become 15 liter. After 2 hours, it increased by 15 and it become 30. After 3 hours, again it increased by 15 and become 45. So you can see in every minute, okay, they've compared minute with liter. So in every minute, it increasing by 15 liter. So since it is increasing equally at equal interval of time, that's why you can say the rate of change is constant. For every 1 minute, the volume is increasing by 15 liter. Okay, and you can see since it's constant, so the graph will be something like this. That is a straight line. So whenever in graph, if you compare two quantity and if you get a straight line, that means the rate of change is constant. Okay, here you can see in 1 minute, the volume is 15 liter, and after 2 hours the volume is 30, and so on. After 3 it become 45. Okay, so you can easily find the rate which you can also call as gradient of this line. Okay, so rate of flow is nothing but 15 minus 0 by 1 minus 0. Why 15 minus 0 by 1 minus 0? You can take any two coordinate. For example, first one and second one, this two will be easy. That is rate of flow, change in volume, which is 15 minus 0 divided by change in time, which will be 1 minus 0. So that's why it's 15 and the unit will be liter per minute. Okay, so till now if there is any doubt, you can ask me in the comment box. So next, okay, so let's solve this question. So here they ask, the table alongside shows the distance traveled by a jogger at 30-second interval. Okay, so they gave a table where they compare time and distance. Time is in second, distance is in meters. So initially it was 0. So after 30 seconds it covered a distance of 90 meter. In next 30 seconds, again it covered a distance of 90 meter. Okay, then at the end of 90 seconds it covered a distance of 270. That is again it increased by 90 meter. Okay, so is the jogger traveling at a constant speed? Explain your answer. So yes, because you can see in every 30 second it's covering a distance of 90 meter. So you can write the statement. Next, number B. Draw the graph of distance against time. Okay, so it will be a straight line. So let me show you how to draw. So let me draw x and y axis. In x-axis I will plot distance, and in y-axis, in x-axis I will plot time, in y-axis I will plot distance. Okay, so distance will start from 0 to 450. So this will be 0, 90, 180, 270, 360, 450, 90, 180, and this is the distance. 270, 360 and 450. So this is distance. I'm just writing D, and here I can plot in x-axis I can plot time, 30 second, 60 second, 90 second, 120, it's given till 150. Okay, so first one 0, that is origin. Next 30, 90, so here 60, 180 here. So if you plot all the point, you will get a straight line, something like this. Okay, so if you use graph paper, you will get a perfect straight line. Okay, so number C. Find the speed of jogger in meter per second. Oh, very easy. So you can take any 2 point. First two will be easy. So speed will be change in distance divided by change in time. So change in distance, you can write 90 minus 0. And in change in time you can write 30 minus 0. So that is 90 by 30. So that will be 3. So 3 meter per second. Meter per second. This will be the answer. So any doubt till now, you can ask me in the comment box. So just now we discussed a sum from constant rate of change, but in every case it will not be constant. So let us come to the example which we discussed in the starting of the video. Suppose you are moving from point A to point B. Now let us assume in first 1 hour you cover a distance of 45 kilometer. In next 1 hour you cover a distance of 42 kilometer. And in next 1 hour you cover a distance of 46 kilometer. Now you can see distance is not same in this case. So that means it's not constant. So in this case we will use average change in rate. So let us discuss that. So average rate of change. You can see graph is not a straight line because it's not constant. So we will find average rate of change using this formula, f of b minus f of a by b minus a. That is change in y by change in x. Okay, so this is also called gradient of chord AB. We'll discuss in details regarding this when we'll do gradient. Okay, so let us do a sum related to average rate of change. So now let us solve this question from average rate of change. So in question this says Alan is driving from Amsterdam to Zurich. This graph shows the distance traveled against time. Okay, so y-axis represent distance and x-axis represent time. Distance is in kilometer, time is in hour. Okay, did Alan travel at constant speed? Answer is no, because it's not a straight line. You can check in first 5 hours it cover a distance of 300 kilometers. So first 5 hour 300 kilometer. Next 5 hour it cover 800. That is 800 minus 3 500. Okay. So in next 5 hour it cover a distance of 500 kilometer. Okay, so it's not constant. Let's do number B. Okay, find an average speed for first 5 hour. Okay, so for first 5 hour, again we have to do the same thing. For speed, change in distance by change in time. So change in distance, so that will be for 5 hour, this is the coordinate 5 comma 300. So that will be 300 minus 0. 300 minus 0 divided by 5 minus 0. So 300 by 5. So 60 kilometer per hour. Clear? Next. Number B. For last 5 hour. So for last 5 hour, you have to take this coordinate and the last coordinate, that is this one. So this will be 10 comma 800. So speed will be 800 minus 300. Let me write 800 minus 300 divided by 10 minus 5. So that will be 500 by 5. That is 100 kilometer per hour. Okay, so in this video we discuss about average rate of change and constant rate of change. In the next class we'll continue this chapter. We'll learn limit and we will learn gradient. So let's meet in another video. Thanks for watching.